Hey guys, it's Wes with AeroAg. Today we're going to be talking about erosion and how we can use drones to do analysis on your field to estimate erosion in different areas. The big key there is that's going to give you insight onto different zones in the field that need additional soil testing. So when we find these places that have high potential for erosion, you're going to lose nutrient differently in that area than you will the rest of the field. It also gives us insight into areas that'll have a high potential for waterlogging. So if we have a hill with a lot of erosion, the bottom of that hill, you may have a high chance for waterlogging. So those are some things we're going to look at there. The model that we're going to use, this is just kind of in the weeds, this is a little bit of nerdy detail, but the RUSLE model, that's the standard model that's used in agriculture for estimating erosion. There's different factors there. The things that we're looking at are rainfall, how much energy there is in the rainfall. So that's a number that we're going to get from a database that's going to show us how much rainfall is expected per year, and that factor is going to be put into the equation to influence how much erosion we're going to have. The next piece is the type of soil we have. Different types of soil are going to erode differently. So clay will wash away a little bit differently than sand, than silt, than loam. So all these different kinds of soil have a different factor in this equation. We can get the number for that based on national maps, or we can find it through observation, taking soil samples, stuff like that. The piece we're going to use drones for is to estimate your topographic factors. So if there's a really steep hill, water will flow down that hill faster, and that's what we're looking to find out with drones. The last piece is cover and management. So the type of crop, whether that's corn or grass forages or sunflowers or any of those pieces, and then how we're planting, how we're tilling, whether or not we're tilling. So all of those things are going to affect how much erosion we have and how much we need to pay attention to erosion in our field. So one of the biggest factors that influences erosion is topography. So areas like the upstate of South Carolina, we have a lot of topography. So there's a lot of hills with steep slopes that are where water is going to wash quickly down the face of that. What we want to do is focus on hot spots. So we're going to target our efforts to zones in the field that we know have higher potential for erosion. So all that means is we're going to find an area, or we'll find several areas and just say, hey, we may want to do some extra tests here, may do another soil sample and send it off to Clemson at some point during the season, just to make sure we're not losing more nitrogen or more whatever here than everywhere else in the field. Because if we're spreading exactly the same thing over the entire field and one place is losing it faster, then we're going to have an area that's growing differently than the rest. Our drones are what we're going to use to do that analysis, so we can identify the terrain and figure out what spots we need to do additional testing on. The reason this is important, because soil erosion and crop yield leads to a depletion in your nutrients. So that reduced nutrient availability could affect your crop yield depending on how much it is. And we want to target our interventions so we can mitigate the impact of that erosion. So the way that we use drone technology in farming in general, there's 3 steps. All right, there's monitoring, data analysis, and application. So we use mapping drones to fly over farms and take images of the fields. We do this on a regular schedule so that we can take that information and put it through our analysis programs, so that we can pull out insights for farmers to give them actions that they can take to increase yield or reduce their expenses on chemicals and inputs. So the example that we're working on today is erosion analysis. So we created a map of this field that we see on the left. We're going to do analysis on that to find areas that have higher potential for erosion. And then the farmer can apply product differently there. They can take management steps to reduce erosion there. They can do additional testing, and then if we were doing an analysis like a weed analysis, we can also use variable rate spraying with our drones to spray different levels of product based on where their problems are in the field. So the methodology for analysis here, first step is going to be identifying the factors. So we're going to do that on the ground. So we're going to go out, identify crop type, soil type, management strategies. We're going to figure that out and collect it while we're out in the field. The next piece is going to be collecting images with a drone. The next piece is going to be creating a point cloud. The next is going to be doing terrain analysis, slope and terrain analysis. We'll use two different pieces of software to determine areas with high slope. And then the last piece, we're going to use the RUSLE calculator to estimate a number for erosion and nutrient loss. So when we're talking about identifying the factors for this calculator, when we arrive on site, we're going to walk with the farmer and talk through these different factors. Figure out what kinds of crops they have, what if there's any management factors that they're doing to manage erosion, observe the soil type. We're going to do all of those things to gather up some of that information. We'll then go double check all that information with databases. So if we go to if you look Google ArcGIS, and you can look up the R factor map, and this is the database that we're looking for right there, USA SSURGO erodibility factor, and that's telling us the soil erodibility factor of different areas. This is the place that we actually did the map example that we're going to work through. And if we zoom in, we can see the soil erodibility factor there, and we'll use that for calculators later. We also want to observe the soil type, because our general calculator, our ag calculator, is going to ask us just specifically for the type of soil. So we want to know both of those. Right, for our rainfall factor, we can go on the EPA website and zoom into that general area, and we can find our rainfall erosivity factor. All right, so that's what we have there. So we want to have both of those numbers for when we put them into our calculators later. All right, the next thing we're going to do in this process is collect some images. So this presentation is not going into depth and detail on how to do a mapping mission. There's other pieces of this course that are going to talk about that. But the first step is going to be flight planning, general overview. We're going to plan the mission in the remote or in a piece of third-party software like Pix4D Capture. Then we're going to run the mission, make sure we have line of sight with the drone the whole time. And again, there's other pieces to this course that discuss mapping in detail. From there, we're going to get into the processing. So we're going to create a point cloud. A point cloud is something like this, right? It looks like a 3D representation of the world, but when we zoom in, we see that each little piece of information there is a little point that has a 3D location and a color. All right, so that's what each point is, and when we put them all together, we have a 3D model of the world. All right, so this is a 3D model of the site that we're going to do the example on. And we can already see when we look around, if we look at this area right here, and we look at it from a profile, we can see that this is a hill. Maybe you can see it's a hill. All right, so there's a hilltop here, and there's a pretty big slope down to the side. And if we look at the bottom, we can see, if we look at the hill, we can see some areas where some grass has been washed away. So this is kind of already looking like an area that's going to have a lot of erosion. But to get that point cloud, what we're going to do is go to our software here. We use Pix4D Matic. That's how we create our point clouds. And we just are going to select images and open it. And from there, we're going to create our project. I'm going to save us the time of creating a new project, because it can take a while. From there, we're going to go to our processing options right here and choose the things that we want the thing to build. So we're going to do calibration. We need a dense point cloud. We can choose this. We don't need the mesh. We're not going to use the digital surface model. We will need a surface model later, but we're not going to use the one we get from here, because it's not going to only show us the terrain. It's also going to include trees and buildings, so we don't want that for here. We also want our orthomosaic, and then we're going to create that mission and export those things that we need. All right, from here, once that processing is done, you'll have a result that looks like this. All right, so we've got a 2D map. I'm going to close that. We've got a 2D map of the area with an overview of everything. And then we have, click over to 3D, we have a 3D point cloud. All right, this step, the actual processing in the computer, can take several hours. So when we're doing this ourselves, we want to make sure that we have plenty of time for the computer to run without being interrupted. We're completely done here. All right, the next thing we're going to do is open it in the next piece of software. So the next step is going to be classifying the point cloud. So we're going to hit File, click Open in Pix4D Survey. When that's done, it'll open the project in Pix4D Survey. So I've got it right here, and it looks really similar. We're going to do a few other steps here. So what we really need to be able to run our script that's going to tell us where we have a lot of potential for erosion, we need to create a digital terrain model. Right? So in order to do that, we're going to just process a few steps here. So if we click on our processing tab, we just are going to run these steps in order, just straight down. That just detects anything that's way away from everything else. We'll run that. The next step is going to be the terrain filter. What this is going to do is classify what's terrain and what's not. So we click here. This is just going to show you what I've already got processed. So you can see the trees are all blue, the ground is all green. So this is going to allow us to create this model of just the ground so we can know what's terrain. From there, our next step is going to be to create a grid of points. This is like a surveyor walking around with a pole taking a shot of each different spot on the ground. And the next piece we're going to do is process that into a tin surface. We click that, and we have our 3D surface model of the ground. Okay, so we want to save those and export them to a file that we can find. The next piece we're going to do is run our analysis to find out the different areas of erosion. All right, so we're going to open up ArcGIS software, and this is what our final result's going to look like. If we look in here, we can see we've got red areas and yellow areas along, let's see, if you notice this hill that we said we thought we were going to have some problems with, we click here, we see that the numbers for erosion there are pretty high. What we're going to do is import all the data. We have to load our orthomosaic. That's what the export is called. It's the overhead 2D image. And our tin, which is that digital surface model we made in Pix4D Survey on our last step. We're going to load those into ArcGIS. That's the software we're using here, ArcGIS Pro. So all we have to do is open them. Once we load a map like this, once we open up the map pane, we will load those into the software by opening them in a file explorer, finding that file, and we just drag it over to right here. So once we drag it over and let go, it'll take a few seconds, but it will load into the map and it will snap you down to a view like, let's see, we'll just do it. We'll zoom to layer. It'll snap you over like this where you can see the entire piece that you just built. So the two pieces we should have are this, the orthomosaic, and the tin surface. This is our surface model, and it showed the lighter color is higher elevation, and we can see that surface model. If we look at this hill, we can see it steps down and has terraces down the side, and we look at the image, you can see this, the same thing we see there. It's all represented. So in order to get the final result we're looking for, this piece, we need to run a script. So that script, we find it just by Googling RUSLE ArcGIS script, like this. And we click here, Soil Erosion Toolbox. And this little download button's not working. You go down here, you can download the file here. Download the file, there's a script you run. The way we do that is we have to find the file and drag it over into the ArcGIS software as well. So once we do that, we'll have a tool available. So we'll have a tool available in our toolbox, which is soil erosion. We'll click on RUSLE. And we'll have a few different options here. We're going to have an input DEM. That's our terrain surface that we have. So we'll just click on that terrain surface. From there, we're going to have our R value, which we remember from our previous Googling we did. Was 317. All right, and then we're going to have a K value, which is 0.31. So we need both of those values. Let's see. we need 317. And 0.31. All right, and our cover and our management practices here, we're going to estimate as 0.01 for both. And we'll click run on the script. And I already have the result here given those. And since all we're really doing here is trying to find where the highest and the lowest values are, if you mess up any of those numbers or you don't have any of those numbers, you'll still pop out a result that's averaged across the field. Like your numbers may be way off. If you click into one of the tabs here, you'll see we have a number, 16.3. If you mess up the numbers, your value might be way off, but the map will still look the same, so it'll still give you the same zones that you need to go do further exploration on. If your map doesn't look exactly right, if you have something way off, or if it looks like this, right? If you have something that just doesn't make sense, we can click on this symbology tab here and choose the color pattern we want. See, where did my colors go? You can choose the color pattern that you want to represent, and if we click over here again, there's some different options to show you how your values are going to be displayed. So you can cut off the highest and the lowest, you can equalize things. The best way to view this is just show standard deviation, which is just going to give you green for good, yellow for medium, and red for bad. So this is going to give you that nice, easy to read chart. So once we see this, the next step we're going to do is quantify the numbers. We're going to go back into Pix4D survey, and we'll take an example of this hill here that we were focused on. We can see this hill. What we're going to do is draw a line and get the slope of it. If we click on the tool at the very top, polyline, we click at the top of the hill, and we'll just find the top there, and go down to the bottom of the hill, and we'll right click to complete the line. We can right click to rotate as well to make sure we're lined up with this actual way the hill is sloping. All right, and we'll right click, and I generally want to move around a little bit to make sure I didn't accidentally put my point on a tree. I'm going to zoom in. We can also open up the images tab, and we can select by choosing S. We can move over to our selection tool, click there, and it'll show us images of what that point actually is on the ground, so we can see that we've got a point on the ground selected. Alright, so now that we've got our line created, we're going to look down here at the bottom left corner of our screen, and it gives us a description. We can change the name if we want, but the things we're looking for, we have our length here, and we have our slope. Alright, so this is the overall slope of this line. So from the top of the hill to the bottom, we have a slope of 16%. If we click here, we can see we have the RUSLE2 calculator, which can be downloaded from online. You just have to Google it, and it's free to download from the USDA. And we're going to click through, we're on the potential erodibility profile. We're going to click through these different options. It chooses the R value, the rainfall value based on your location, so we'll click there. Choosing the soil type will determine that K value. So we're going to go to generic soils, and the soil type we had out there was like a silty clay, so we're going to find one of those. Or actually a sandy clay. We're going to find sandy clay with low organic material. Then we're going to get our slope length and topography, which is 316, which we just found. And we're going to choose a type of grass. So this is a grass. We're going to choose the type of grass that fits it the best. Right? And then we don't have any supporting practices or any other inputs we need to put in. So what we're going to get out is this number here, which is our soil loss in tons per acre per year. All right, so 27 is our estimated soil loss. So we can use this to estimate our nutrient loss based on any soil testing you have. The way you do that, you just take your overall pounds per acre that you have of a certain nutrient, and you'll just divide it out to figure out how much is going to be lost for that erosion. This is just a slide that's showing you the same thing we just did. And the big thing we're doing here is doing this analysis to kind of identify areas that we need to put attention on. We're going to get soil testing zones just to say, hey, on this hill, we need to pay a little more attention to this hill than we do this flat pasture area over here. We can do broad soil testing over the whole thing, but when we're looking at nutrients and we're figuring out how much fertilizer we need to apply, let's separate out this and do a separate test on this area so we can see, is it different than this area, right? And then we can also have management decisions like, are we going to do a second fertilizer application here? You can put some foliar fertilizer, and we do that with drones. So with our drones, we can do advanced fertilization techniques. So we can spray fertilizer, and the biggest benefit here is if you put out fertilizer everywhere and we use this to find specific areas that you need to test separately, then we can come back in with a drone and apply fertilizer specifically to those areas. We can also do some correlation analysis, so we'll figure out, so when we do our comprehensive monitoring where we visit the site multiple times throughout the year to do different analyses, like we're doing erosion here, but we can also do weed management, we can do plant health at different times. We can see, is there a link between these areas with more erosion and how well the grass is growing in this area? Or if we were looking at corn, is there a link between erosion and weeds? So this can kind of give us some information that we can use over time. We're going to track those changes to refine our strategies. And that's everything. That's how we use drones to map out a field to figure out erosion and use that to inform our fertilization and nutrient management strategy.